Hello, today we're going to be discussing operons. So we're going to answer a few questions to help us better understand the difference between inducible and repressible operons, as well as the difference between positive and negative operons. So first, with the positive inducible operons, let's start off with that word positive. So the positive operons, with positive operons, the regulator is always going to be an activator. So right here we have a positive inducible operon, and so our regulatory protein is an activator. So this first question, does the regulator stimulate or inhibit transcription? So the activator is actually going to stimulate transcription, as its name kind of gives away. It activates the operon, or it stimulates transcription. So stimulates. So will the operon normally be active or inactive? So when I'm thinking about the difference between inducible and repressible, I remember that inducible operons are usually off. They're usually off, so they're not being transcribed usually, but we can induce them and so that they can start being transcribed. So we can induce them so they can turn on. So that means that inducible operons are normally inactive. So in this situation, the substrate will bind to the activator, making it active. And so now that it's active, it can bind onto the operator and stimulate transcription. So this is why transcription is on here. Now moving on to positive repressible operons. So that positive word, remember, it means that we have an activator as our regulator. So as we talked about, the activator is going to always stimulate transcription. So stimulates. And will the operon normally be active or inactive? So thinking about repressible operons are usually on, or they're usually active, but they can be repressed. So we can do something to repress these operons so that we can stop transcription from happening. So it is usually active. So here we see that with the repressible operon, or specifically positive repressible, the signal will bind to the activator and make it inactive, sorry. It will make the activator inactive so that the activator can no longer do its job. It can no longer bind to that operator. And because it can no longer bind to the operator, transcription is turned off because that activator is what would stimulate transcription to happen. But since it's inactive now, it can't do its job. It cannot stimulate transcription. So we have transcription being turned off here. Now with negative inducible operons, let's start off with that word negative. So negative means that we have a repressor as our regulator. So this repressor, like its name suggests, inhibits transcription. It causes transcription to be inhibited or to be turned off. So inhibits. And this operon is inducible. So remember that inducible operons are usually off, but they can be induced. They can be induced to turn on. So we can get them to become active once we do something about that, once we have something happening to make them on. But they are usually inactive. And so with negative inducible operons, the substrate will bind to the repressor, making it inactive. So we have an inactive repressor here. And now that that repressor is inactive, it can no longer do its job. It can no longer bind onto the operator site. So now we have transcription occurring because there's nothing that is blocking the polymerase from binding onto the DNA and transcribing it. So we have transcription happening. Transcription was induced here. And lastly, with negative repressible operons, again, that word negative means that we do have a repressor as our regulatory protein. And repressible means that the operon is normally active, as you see here. Transcription is normally on. So the operon will normally have transcription happening, but we can cause the operon to become inactive if the signal binds onto the repressor, causing it to become active. So here we have an active repressor. And so now that repressor is active, it's going to do its job. It's going to bind onto the operator and inhibit that polymerase from binding. And this in turn turns off transcription. So the regulatory protein inhibits transcription, and the operon will be, normally it will be active here.